Okay, this is lesson 4.2b. So we're talking about the placebo effect. This is actually a thing. You've probably heard about it. And this is when you're in an experiment and you don't, even if you're not given a drug, you think you oftentimes make better choices. I'm part of the experiment. You think you're taking maybe a drug that will lower your cholesterol. And so you might be even making better life choices. It might be mental, but usually there's some kind of placebo effect. So even if let's say that, half the people in the study were given, and then in the experiment were given a cholesterol lowering drug. Half the people were given a placebo, which is a fake drug, like a sugar pill. Usually the people who are given the sugar pill will have some slight decrease in their cholesterol. We're hoping, as the experiment goes on, that maybe the cholesterol-lowering drug will have a much bigger effect than the placebo effect, but we're going to use them as a control group. And so just knowing that you might be a placebo is a different thing. So it also can be effective because human nature says that the experimenter wants this experiment to be successful. So it's great if this can be possible. It's not always possible, but if it's a double blind, that means the person who's giving you the pills has no idea if it is actually a pill with the cholesterol lowering drug or if it's just a sugar pill. They have no idea. And you, as the person being experimented on, also don't know. So both of you don't know. It's called double blind. There's also single blind, and that's where, for whatever reason, it was too difficult for the experimenter to be kept in the blind about it, and so he or she will actually know what they're giving you, but you won't know as the person being experimented on. So that's called single blind. Random assignment is super important. We're going to do activity about that a little bit, but it goes towards causation. We don't want to just pick out people we want to randomly assign. So that means that they are assigned to treatments randomly. So we don't just choose, these 10 get this, because we want them to have a roughly equal chance of being chosen. So here are some methods we could use. The first one is the most basic, but it's pretty good. If you had 20 slips of paper, you would put the 20 student names or experimental unit names on those pieces of paper, maybe put them in a hat, shake the hat to randomize. It's an important point to mention. Grab out 10 of the names from the hat. Everyone has an equal chance of being selected, and you have a randomly assigned 10 people to drink the caffeinated soda, and then the other half have been randomly assigned to drink the non-caffeinated soda using technology. So with technology, you can do this. So you can actually, there's a command you can use. So let me just show you this. So if you go to menu, probability, I believe, and then it's random. And so there's a bunch of commands. The one we use a lot is random integer. If you don't know that command, hit the catalog key down here and look up the random integer in the catalog. Randint says this: lower bound, comma, upper bound, comma, number of trials. So if I wanted, say, 25, I want 20 numbers for this one. So 1, comma, 20. So I'm just going to randomly pick numbers from 1 to 20, and you want to pick 10 of those folks, so 10 people. So it would do that. So it's going to randomly choose 10 of those. Now you might have to do more than 10 because you might have to ignore repeats. This command does potentially have some repeats. You can see 9 is repeated there. So maybe I should have done, to 15 here and pick 15 numbers, and now pick them left to right. The first 10 numbers that do not repeat would be in the caffeine group in this case. And so that's one way of randomly choosing, using a calculator to do this. So you're using the randint command to do that. Or a computer, you could talk about a computer generating a random list of numbers. That'd be okay to talk about. Table D is when you have kind of a random number generated table. And so you would talk about things like, we're going to take 2-digit numbers from left to right. We're going to ignore repeats. And we're only taking numbers 1 through 20. We've assigned every student a number. That's the first thing we did. And there's a stopping mechanism. Maybe you say that after 10 people have been chosen, they are chosen, you're done picking the caffeine group, and the rest will be automatically put into the no caffeine group. Here are the written answers there. Okay. What is a control? So oftentimes we want to control other variables than the one we're actually studying. So we'll kind of keep them constant or control for them in some way. So we want, it's just going to help our results be more about the variable we're studying, because sometimes other variables will creep in and cause issues. So in experiment, replication means you're using enough experimental units. So it doesn't mean you were doing the study over and over and over. It means that we're not testing just 20 people here. Maybe we're testing 200 people, right? That would be a big difference, because 20 people, chance alone has a much bigger effect. But if 200 people, you know what? That's probably, the results are probably due to whatever variable we're studying. So we can make more of a case for that. Other subjects, like psychology, might use replication in a different meaning, but this is our meaning for replication. So it doesn't mean we're doing the study over and over. It means we have a large enough size group that the results are not due to chance alone. I actually really like these 4 principles. I think they're really good to talk about and know and understand. First is comparison. We want to be able to compare 2 groups. Usually that's the control group, they get the placebo, and the real group, right, which gets the drug that we're studying. Random assignment, so we definitely want to assign people randomly. Do not just go half and half here, but you want to choose them randomly. That helps us prove causation. And I love this wording here. It assures that we might get roughly equivalent groups, or that's our goal. We want to get roughly equivalent groups. And random assignment is the way we get roughly equivalent groups. That's the wording we're looking for there. Control. We're going to control some other variables. We'll see what that looks like in a second. We'll do a good example in a few minutes. But it avoids some of those confounding and reduces some of the variability in the whole trial. Replication is using enough people or enough experimental units in the experiment that you're doing so that we can distinguish between chance and just know what happens. Okay, so Rivers is credited with creating the first double-blind experiment in 1907. He wanted to find out about caffeine and its effect on work. So he quickly discovered the psychological effect on subjects who knew that they were receiving a treatment. This led him to create a placebo for each experiment, which looked and tasted like the real caffeine treatment. Rivers would have a friend prepare caffeine drinks and placebo drinks, non-caffeinated, and would give the drinks to the subjects. So if they know they're part of a study, they might change their behavior, right? So that's basically what he found out. So explain what it means for the experiment to be double-blind. So if it's double-blind, that Rivers, when he gives out the liquid, he has no idea if it's caffeinated or not. And the subjects who drink it have no idea if it's caffeinated or not. They can't tell. Why is it important for this one to be double-blind? Because as an experimenter, you want this to work out. You want this to, your caffeine to be the thing you've been studying. Oh, man, it makes such a difference in lifespan or whatever it is we're studying. And so we might be tempted, our human nature is to maybe fudge the results a little bit. But if we don't know which group is which, we won't be able to fudge the results at all. Again, it accounts for the placebo effect. And now we have a group to compare to because we're going to compare to the placebo group. And so by having 2 groups and not knowing, you're going to hopefully treat both groups the same way. So that's really the goal there. So school set up an experiment where 500 geometry kids were randomly assigned. So 250 took the online course, and 250 were lectured by a teacher. Now they kept something the same, right? They controlled for some things. Same teacher was used for both courses. They both met for 58 minutes per day. They both took the same final exam, right? So at the end of the year, they were going to measure the students' progress by the scores on the final exam. So how is this? How did they use comparison? We're comparing the online students' results, test scores, to the in-class student results. So the 2 treatments were an online course and a teacher-taught course. I would prefer the teacher-taught course, but some people prefer the other. Explain the purpose of randomly assigned students to two treatments. Remember the purpose of random assignment? We want them to have roughly equivalent groups, right? So by doing randomly, we hope that the two groups were roughly equivalent at the beginning of the experiment. Hopefully at the end, there might be a difference. Two variables that were controlled. So it looks like the time was the same. They controlled that. They made it constant. And the teacher was the same. Essentially, also, the final exam was the same. So they did a lot of control on this one. It helps reduce variability in the results. And did this experiment use replication? So again, replication is how many students were tested. 250 of each? Man, that's great. So this definitely used replication because we had more than enough to prove that it wasn't just chance alone that is causing the differences here. Great, that is your lesson for today.